Hello and welcome. In this video we're going to take a look at some of the new functionality developed in-house to assist with the multi-body to CAM or nesting workflow. So to start off with, I've just got a multi-body we're going to use, pre-created. I'm going to open this in SOLIDWORKS. As you can see, this is a pretty standard multi-body. There are also a set of shelves and drawers inside here, along with all the relevant holes for all the connectors as well. So the first thing we're going to do is we are going to save this out into an assembly. So you may be aware with multi-bodies, you have the option to actually create a save bodies, which will change your multi-body into a part and assembly model. The first thing to take into account though, is when we do a save bodies, we actually have the option here to choose a part template to change it to. With the new functionality, there is one thing to take into account, and that is the part template that's going to be used. So if I use this part template here, which I've just called part Z, you'll see this already has a set of CAM. So it's already got the contour, the pocketing, and the auto drilling set up. And the orientation is correct in regards to the Z. We close this down and simply go to right click Save Bodies. I'll first change my template to Z. And I'll also save this under here as panel macro example. Once that is done, I can choose this option here to auto assign names. That will just give each of these bodies a name. You may want to at this stage change some of these names, as these will be the names that your actual parts will be called once created, and simply just click the green tick. Okay, so once the Save Bodies feature has run, we still have our multi-body part, but if I switch documents here, you can also see we now have our part and assembly model. So each body in the multi-body part has now been converted into its own part. So the issue that was found previously with multi-body to CAM method and workflow was the fact that the multi-body, all bodies shared a single coordinate system. So every single of these bodies, the X, Y, and Z axes are all the same, which means for some of these parts, that's fine, they're already in the Z upwards direction, which is correct. But some of the parts aren't. So in this case, X would be upwards, which isn't really what we're after when it comes to the CAM side of things. If we take a look at one of these parts here, if I open this up, we can see that if I look at my CAM at the moment, you'll notice that the Z is actually pointing in the wrong direction. So if I try to rebuild at this stage, and let's say simulate, you'll see here it treats it as being the wrong way around. But if we give this a save, the new functionality that's been developed in-house now allows us to actually run a macro to reorientate all these panels automatically for us. So if I run this panel orientation macro here, so once this macro has been run, if I open up the same part now and give my CAM a rebuild, you'll see that the panel has been automatically reorientated. So now when I simulate it, you'll see that the contour is in the correct orientation. There are no pockets, so it just ignores that. And if I simulate the auto drill, it's now automatically picked up all those drillings for me. And that has done that every single panel on here. With that logic, if I actually run a SWOOD design report or a SWOOD CAM report at this stage, that will actually take every single one of these components that already have the CAM in there from the template and will produce a program for me, which you'll see once this report has been run. Okay, so now the report has been run. If we expand out the documents and start off with open up just the HTML, we can ignore the SWOOD design tabs for now and go straight to the programs. You'll see every single panel within here now has the correct orientation, a program associated to it, and also, if needed, a label associated to each program. If we open up the file location for this now, you'll also find a folder with every single program as well. For the nesting workflow, now that all the panels have been reorientated, all we have to do is make sure there is a material added to it. So this material could differ from panel to panel, but for the simplicity of this video, I'm just going to add the same material to all panels. Just simply called wood in this case. Okay, so once that's been applied, I'm just going to click close, and I'm going to give my document a save. Whilst I have applied a single material, there are a range of different thicknesses within the model. When we get to the nesting stage, the nesting software will separate the different thicknesses of material and assign them to different boards, as you'll see shortly. Once this has been done, we can go to Tools, SwidCAM, and Nesting. And you can either right-click and add source files in this manner, or if you've got the location of where it's saved, you can simply drag the assembly on top of where it says source files. You'll see now that each of my parts have no red on them, which means that they're all possible to be nested. And if we quickly just have a quick look at my boards library, you'll see that I've got a set of materials for each different thickness that I possibly could use in this case. If I set a few options here, so I set my tool diameter to be 16mm with an extra offset of 2mm. Once that's done, I can click Rebuild. Once that's rebuilt, you'll see an example of all the nests on the bottom right hand corner. Even though this has been modelled up in SOLIDWORKS without the use of Swid Design, I can still go to manual nesting. And if needs be, I could make any changes to the position, the order, or the type of nesting that I'm going to be doing here. If I click the green tick to accept, assuming I'm using the same CNC that I used to set up my part template, if I click the green tick to accept this, it will create an assembly of that nest for me, and using the CAM toolpath supplied at the part level, it will actually insert them into the nest for me. So as soon as this has been run, I actually have a fully functioning, fully programmed nest. There may be a few small tweaks you may need to make, and it's always worthwhile double checking to make sure all the panels are the correct way around. But if I just have a quick flick through here, you'll see all of the programs have been brought through. And if I click through here, you can see all of the programs. We have a total of 9 sheets in this instance. And similar to how we run the report at the single panel stage, if I run the report at this stage, once the report has been run, if I expand this out, and again open up the HTML, and this time go to the nestings page, you can see I now have an image for each of my nests, with a location of where each of my programs has been saved. I can also click onto any of these sheets, and I can see the tools that are being used, and I can also dig down further and actually see the program itself. Again, each of those programs will be exported out automatically into a folder in the same location of the SWID report. Hopefully you found this video interesting. If this sort of functionality is useful to yourself, then please contact your manufacturing RSM for further information.